The universe is weird, and we love it. The universe is vast, mysterious, and sometimes downright bizarre. For centuries, we've looked to the stars and asked strange questions. Why is space black? Could we survive without the moon? What's at the edge of the universe? And could time travel ever be real? In this video, we're diving headfirst into the weirdest, wildest space questions and using real science to explore the answers. Get ready to rethink everything you thought you knew about the cosmos. Why is space black? When you look up at the night sky, you're looking at space, and it's mostly pitch black. But why? The universe is full of stars, galaxies, and light. Shouldn't space be glowing? This question is known as Olber's paradox. If the universe were infinite and eternal, the sky would be bright in every direction because there would be stars everywhere. But the universe isn't infinite in age. It had a beginning. Light from the most distant stars hasn't had time to reach us yet. Also, the universe is expanding, and light gets stretched, losing energy and becoming invisible to the eye. That's called redshift. So space isn't black because it's empty. It's black because we're still waiting for most of the light to arrive. What happens at the edge of the universe? Does the universe have an edge? If you flew far enough in one direction, would you hit a wall or fall into a void? Here's the strange truth. The universe might not have an edge at all, even if it's finite. Just like how you can walk around the Earth without falling off an edge, space might curve back on itself. According to general relativity, space can bend and wrap, depending on how mass and energy are distributed. Some models suggest the universe is finite but unbounded like the surface of a sphere, but in higher dimensions. Even more mind-bending, the universe is expanding, and the space itself is stretching. The edge isn't a place, it's a moment in time. We can only see as far as light has had time to reach us. Since the Big Bang, about 46 billion light years in all directions. Beyond that, it's not that there's nothing. It's that we can't see it yet. And some theories suggest the universe is truly infinite, no edge, no boundary. Just more space, more galaxies. Forever. Could we travel faster than light? According to Einstein's theory of relativity, nothing with mass can move faster than light. As you approach the speed of light, your energy requirements become infinite. So, faster than light TTL travel is impossible, right? Maybe not. Physicists have imagined some loopholes, ways to bend space rather than moving through it. One of the most famous is the Alcubierre drive, a theoretical concept where a spacecraft compresses space in front of it and expands space behind it, essentially riding a warp bubble. Inside the bubble, you're not moving faster than light, but the space around you is. Another idea: wormholes, shortcuts through space-time that connect distant points. If they exist and are stable, they could allow near-instant travel across vast distances. The big problems? We don't know if warp bubbles or wormholes can be created or controlled. They may require exotic matter, negative energy, or other things we haven't discovered yet. So for now, TTL travel is science fiction, but the laws of physics don't completely rule it out. What is the universe expanding into? We've all heard that the universe is expanding. Galaxies are moving away from us. Space itself is stretching. But into what is it expanding? Here's the twist. It's not expanding into anything. There is no outside of the universe, at least not in the way we normally imagine space. When scientists say the universe is expanding, they mean that the space between things is growing. Galaxies aren't flying through space, the space between them is increasing. Think of the universe like a balloon covered with dots. As you blow it up, the dots move apart, not because they're moving, but because the surface is stretching. But in this analogy, the balloon expands into air. In reality, the universe isn't expanding into any higher dimensional space. It creates space as it expands. So what lies beyond the edge? If the universe is infinite, there is no edge. If it's finite, it still might have no boundary, just like Earth's surface in both cases. No outside, no beyond, just more space coming into being. Can the universe think? It sounds like science fiction, but some scientists and philosophers have asked, could the universe itself be conscious? Or at least, could it process information in a way that resembles thought? This idea is linked to a theory called panpsychism, the view that consciousness is a fundamental property of the universe, like space or time. Some versions suggest that everything has a tiny spark of awareness, even atoms. But there's more. Physicists like Seth Lloyd have proposed that the universe is a quantum computer, a system that stores and processes information on a cosmic scale. In that view, galaxies, stars, and particles are like the circuits and data of a giant program. Even the laws of physics might be emergent code, unfolding over time. So maybe the universe doesn't think like a brain, but maybe it computes like a mind. If so, the emergence of our consciousness may not be a coincidence, but a natural part of the universe becoming aware of itself. Is time real or just an illusion? We experience time as something that flows from past to present to future. But in physics, time doesn't work that way. In Einstein's theory of relativity, time is just one dimension of spacetime, like space. It can stretch, bend, and slow down. Some physicists propose the block universe model, where all of time already exists. Past, present, and future are equally real, like pages in a book. You just happen to be on one page right now. Others suggest that time is emergent, not fundamental. In quantum gravity, space and time might arise from something deeper, like information or entanglement. In this view, time is more like a mental construct, a way our brains interpret change. So, is time real? Yes, but maybe not in the way we think. It might not be a flowing river, but a frozen landscape we're slowly discovering. Could Earth be destroyed, and how likely is it? It's a scary thought, but not science fiction. There are real cosmic events that could destroy Earth, or at least wipe out life as we know it. Let's look at a few possibilities. Asteroid impact. This one's well known. An asteroid just 10 kilometers wide wiped out the dinosaurs 66 million years ago. NASA tracks near-Earth objects constantly, but we're still vulnerable to surprise impacts. Gamma ray bursts. These are the most powerful explosions in the universe. If one happened in our galactic neighborhood and was aimed at Earth, It could strip away the atmosphere and cause mass extinction. Rogue black holes. A black hole drifting through space could pass close enough to disrupt Earth's orbit or even swallow it. Extremely unlikely, but technically possible. Solar superstorms. A massive solar flare could fry satellites, knock out power grids, and collapse global infrastructure. It wouldn't destroy Earth physically, but could paralyze civilization. Artificial disasters, nuclear war, uncontrolled AI, or experiments with high-energy particles could cause catastrophic chain reactions, though this is debated. Still, most of these are rare or extremely improbable, but they remind us Earth is not invincible. Our safety depends on science, observation, and preparation. Is our universe a simulation? It sounds like science fiction, but some scientists, philosophers, and even tech billionaires take this idea seriously. What if everything, stars, galaxies, your memories, this conversation is part of a simulated reality? The argument is known as the simulation hypothesis, and it was popularized by philosopher Nick Bostrom. It goes like this. If advanced civilizations can create ultra-realistic simulations, and they create many of them, then statistically, most beings would live in simulations, not in base reality. From this logic, it might be more likely that we are simulated rather than real. Add to that, quantum mechanics shows strange, probabilistic behavior, like a video game engine rendering things only when observed. The universe seems to follow mathematical rules, like a coded system. There are fundamental limits like Planck length and the speed of light, similar to processing limits in computing. But there's no solid evidence yet. Some physicists propose tests like looking for pixelation in the cosmic microwave background or anomalies in quantum behavior, but so far, we can't confirm or deny it. So are we in a simulation? If we are, it's the most incredible simulation ever built. And maybe that doesn't make our lives less meaningful, but more. What if it's all true? Each of these questions is not just a mystery to science. They are a window into our own nature, into who we are and how we exist. When we ask, why is space black? What would happen if the moon disappeared? Is there an edge to the universe? We're not just looking for answers, we're looking for meaning. And here's what I think. Questions are more important than answers. In a world where much seems to be known, it is such strange, seemingly childish questions that are the real fuel of progress. From them, new theories, discoveries, ideas are born. Our whole reality is like an experiment. Quantum physics, simulation theory, the block universe, these are not just oddities. They're clues. Maybe reality is arranged far more intricately than it seems. And we are at a moment in history where humanity is just beginning to realize what the behind the scenes may be behind what we call the physical world. Consciousness as code? The idea that information is the foundation of existence and consciousness may be part of the cosmic operating system sounds crazy. But if you think about it, isn't that what makes us unique? That we are aware of the universe, and it may be realizing itself through us. My main feeling is admiration. Whether it's a simulation or not, the cosmos remains the greatest work of art, and we are a part of it. No matter what side of reality we are on, we think, we ask, we search. And that's the real magic. If these questions have made you think, that's good. Science is not only about knowledge, but also about curiosity, about inquiry, about the courage to ask strange questions. And maybe it is through such questions that humanity will one day transcend its illusions and look into the heart of the universe.